Good evening, girls. Are you there? Both of you, Roshni and Shreya. Good evening. So, can we continue with exercise 10.3? Okay. So, in exercise 10.3, the first problem is draw different pairs of circles. How many points does each pair have in common? What is the maximum number of common points? So, we need to be drawing pairs of circles. You can draw two circles like this. Okay. You can draw two circles like this. You can draw two circles like this. Okay, so in this case and in this case, you can see that there are two circles which touch only at one point. Okay, so they have one point where they intersect each other. In this case, you can see that the circles intersect at two different points. Is there a way to draw two circles in such a way that they intersect at 3 points? It is not possible at all, right? So there can be circles which touch just as one at one point, or they can touch at 2 points, or they can be two independent circles not touching at all. Something like this. Something like this. So you can identify different such pairs of circles which do not have a common point at all. They do not touch or intersect each other at all, or there can be one point of intersection, in which case one circle and the other circle will be, in this case you can see that one circle is within the other circle. They touch at one point. Here both the circles touch at one point, which is, none of these circles are inside any one of the other, right? So these are two circles which intersect at 2 points. So there can be no common point of intersection, or there can be one point of intersection, or there can be 2 points of intersection. You cannot identify two circles passing through three common points. Okay, so that's the answer for the first problem. The next one, suppose you are given a circle, give a construction to find its center. So you've been given a circle. You need to find out the center of this circle, for which you'll be drawing two chords, any two chords. Okay. you should identify two chords, okay, in such a way that if you join the two chords at all the three vertices or at all the 3 points A, B, C, these three are points which lie on the circle, and you can identify two chords AB and BC, or even AC. Just identify two chords with a common point, say B. Okay. Now you need to draw a perpendicular bisector to this, and then you need to draw a perpendicular bisector to BC. Now this point will be the meeting point of these perpendicular bisectors will be the center of the circle. Okay. So if you're just given one arc, and if you need to find out the center of the circle which will complete which which is formed when you complete this arc, you need to draw two chords again. Okay, so if, even if it is just an arc that is given, you can find out the midpoint, I mean, or the center of the circle which will complete this arc by just drawing two chords with a common point. And then you'll draw the perpendicular bisectors of these two chords. The point of intersection, that is the point where the two perpendicular bisectors meet, is the center of the circle that is formed. Okay, so that's how you'll solve the second problem. Did you understand, both of you? Okay, so let's get on to the last one of this exercise. So if two circles intersect at 2 points, prove that their centers lie on the perpendicular bisector of the common chord. So let's draw two circles, and these are the two circles which intersect at 2 points. We already drew such pair of circle in the for the first problem. So these are the two circles. You can see that they intersect at 2 points. Let's name the points as A and B. Let us assume that their centers are P and Q. So P is the center of this circle and Q is the center of this circle. You can see that there is a common chord. Okay, you can see that AB is a chord for the circle with center P. It is also a chord for the circle with center Q. So AB is a common chord. You need to prove that the centers lie on the perpendicular bisector of the common chord, which means you're going to now join the centers. This line, what you are supposed to prove is that you will prove that this PQ bisects the chord AB at right angles. Okay, that's what you need to prove. So if you want to prove that that the what is given? Prove that the centers lie on the perpendicular bisector of the common chord, which means you need to prove that PQ is the perpendicular bisector of AB. That's all. So it is worded in such a way that it sounds very complex, but it is a very simple thing. All you need to do is to prove that PQ is perpendicular to AB and also PQ bisects AB. This is what you need to prove. You need to prove that PQ is perpendicular to AB and PQ is the bisector of AB. This is all you need to prove. Let us mark this common point as O. You're going to join AP, join all of these. Okay. Now, can you prove that triangle APQ and triangle BPQ are congruent? Triangle APQ and triangle BPQ. They are congruent by SSS congruence because AP and PB they are equal. Why are they equal? Because they are the radii to the circle with center P, and you can see that BQ equals AQ. And then you can see that PQ is a common side to both, right? So by SSS congruence, you can say that triangle APQ is congruent to triangle BPQ. Okay. So you have to prove that this angle is a right angle. For that, you need to prove that triangle AOP and triangle BOP are congruent. If you do not prove this congruence, then we will not have enough properties of these two triangles to prove that these are congruent. Say for example, now just like that, if you want to prove that triangle APO and triangle BPO are congruent, what can you say about it? You only have PB equal to AP and you have PO as the common side. That's all you have. You cannot find any angles or any other sides of these two triangles equal in order to use SAS or SSS or AAS or anything. Because all you know is that AP and PB are equal. That's all is known. So what we are first doing is to prove that triangle APQ and triangle BPQ are congruent. Using this, the CPCT for this, we can say that angle APQ equals angle BPQ, isn't it? Angle APQ will be equal to angle BPQ. So when these two angles become equal, now if you consider triangle APO and triangle BPO, you can see that angle APO equals angle BPO, and then you have the sides AP and PB, and then you have the common side PO, right? With which you can prove that triangle APO is congruent to triangle BPO using SAS congruence, correct? So first you will take these two triangles, that is APQ and BPQ, and prove that they are congruent, and then by CPCT you can say that these two angles are equal. Then you will consider the triangles APO and triangle BPO, and then prove that these two triangles are congruent. So when they become congruent again by CPCT, so if triangle APO is congruent to triangle BPO by CPCT, angle AOP will be equal to angle BOP, right? By CPCT. But then AB is a straight line is known to us, correct? Therefore, angle AOP and angle BOP will add up to 180 degrees. But since the two angles are equal, each of these will be equal to 90 degrees. Also by CPCT, you can say that AO equal to BO. So in order to prove that that is PQ is a perpendicular bisector of AB, you need to prove that AO and BO are equal. That is one thing. You should also prove that angle AOP equals angle BOP equals 90 degree. Both are to be proved. So once you prove that triangle APO and triangle BPO are congruent, you are done with the proof for AO equal to BO by CPCT, and also by CPCT you know that angle AOP equals angle BOP, but when they add up to 180 degrees, each of these will be equal to 90 degrees, which proves that PQ is perpendicular to AB. We have proved that PQ is perpendicular to AB. We have also proved that AO equal to BO, hence proving what is required to be proved as asked in the problem. Did you understand, students? So at the end of the class, I would like both of you, after the class, I would like both of you to write exercise 10.3, all the problems. I have explained you everything. All the three problems, you will work them out and send it across to me over WhatsApp right after the class. Okay. So now we are going to go to the next exercise. Exercise 10.4. See, in exercise 10.4, the first problem, two circles of radii 5 centimeter and 3 centimeter is intersect at 2 points, and the distance between their centers is 4 centimeter. Find the length of the common chord. I am giving this. See, whatever we have just proved, same thing we are going to make use to prove this, to find the value. Can you think about this problem and do it yourself? So it's been given that this is 3 centimeters, this is 5 centimeters. Distance between their centers is, it's given as, what is given? It is 4 centimeters, it is given, right? So this entire thing is 4 centimeters. Actually, I would suggest that you draw two circles. You should draw two circles of radius 5 centimeter and 3 centimeters and find out the length of the common chord. That is the best thing to do. That is more practical a way to understand this problem. Okay, so I'm giving this also as an exercise for you. Do this problem. Okay, draw the two circles and find out the distance of the common length of the common chord. Okay, the next one, if two equal chords of a circle, so if two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to corresponding segments of the other chord. So there are two chords AB and CD, and they've been given that they are equal chords. So let us assume that they intersect at the point P, and this is the center of the circle. Okay. So what is given in this problem? We've been given that AB equal to CD. We need to prove. Let us understand what is to be proved. So when two chords intersect, then the chord is cut into two segments, correct? The two segments are, each chord is cut into two segments. One segment is AP and the other segment is BP. Here, one segment is CP, the other segment is PD. You need to prove that CP and PB are equal and AP and DP are equal. This is what you need to prove. So to prove AP equals DP, these are the corresponding segments, and CP equal to PB. So let us get on to the proof of this problem. What do you know about equal chords of a circle? Equal chords of a circle. Equal chords of a circle are equidistant from the center, isn't it? So OL is the perpendicular distance of the chord AB and OM is the perpendicular distance of the chord CD from the center O. Therefore, OL and OM are equal. Correct? So if we just join this OP, we can prove that triangle OLP and triangle OMP are congruent. How do we prove triangle OMP and triangle OLP are congruent? You have right angle. The side opposite to the right angle OP for both the triangles are common. And then you have OL equal to OM. Therefore, by RHS congruence, you can say that triangle OLP is congruent to triangle OMP. So, by you should be expanding these steps. You cannot be writing just like how I am writing now. You need to write, consider the two triangles and prove that they are congruent using RHS. In 3 steps, you need to clearly write that you are proving it by RHS congruence. So by RHS congruence, triangle OLP is congruent to triangle OMP, which means LP equal to MP, right? So therefore, LP is equal to MP. Let us mark this as 1. Now we know that AB equal to CD, which implies half of AB is equal to half of CD. Now what will the perpendicular from the center to the chord do to the chord? It will cut it into two equal parts. The perpendicular drawn from the center onto the chord will bisect the chord, which means AL and LB will be equal. So if I write half AB, I can write it as AL. So AL equal to, what is half of CD, we can write it as DM. Correct? So AL equal to DM. So this is 2. Now add 1 and 2. When you add 1 and 2, you'll get LP plus AL equal to MP plus DM. What is LP plus AL? It is nothing but AP. What is MP plus DM? It is nothing but DP. So we are done with the first proof. Okay. So hence proving the first one. Now from AB equal to CD, let us mark this as A. Okay. From AB equal to CD. Now do A minus 3. When you do A minus 3, you'll get AB minus AP is equal to CD minus DP. AB minus AP. What is AB minus AP? It is nothing but PB. What is CD minus DP? It is nothing but CP. So we have now proved that BP equal to CP. This is also proved. Okay. So there ends this problem. This is also a very simple problem. Did you understand, both of you? Okay. Let's get on to the next one. If two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center makes equal angles with the chords. It's so easy. We have already done this problem here in this. So the line joining the point of intersection with the center, same diagram you can make use. So if two equal chords intersect within the circle, prove that the line joining the point of intersection with the center makes equal angles with the chords. So you need to find out the angle between OP and the chord CD. The angle between OP and the chord CD, it is nothing but angle OPD. The angle between AB and the line joining the center and the point of intersection OP. The angle between the chord AB and OP will be angle OPA. Right? So now that we have proved this congruence, triangle OLP is congruent to triangle OMP. We can also say that by CPCP, angle OPL equals angle OPM. Right? From here only we can prove. Which means that they make equal chords, equal angles with the line joining the center to the point of intersection makes equal angles with a chord. That's all. Okay. Now I want you to send the proof of problem 3 alone now. Roshni, good. You have done it correctly, but for OE equal to OE, you should write common hypotenuse. So you should somewhere say that you have made use of RHS congruence. That is very important. Okay. Shreya, correct. In the given you have written they are chords with center O. They are equal chords. That is very important. So the next one, if a line intersects two concentric circles with the same center. Okay, so you have two circles. Concentric means they are two circles with the same center. Okay. And you've been given that there is a line that intersects the two concentric circles at A, B, C, and D. You need to prove that AB equal to CD. It's a very simple problem again. Drop a perpendicular onto the chord, name it as OL. Okay. So there is this line which passes through 4 points of the two circles A, B, C, D. Okay. You need to prove that AB and CD are equal. So in order to do that, drop a perpendicular from O onto the chord. The perpendicular from the center will bisect the chord. So BC is the chord of the inner circle. AD is the chord of the outer circle. BC is bisected. AD is also bisected, right? Because OL is perpendicular drawn from the center onto the chords. So BL equal to LC. You also have AL equals LD. Okay, just subtract AL minus BL equal to LD minus LC. So what is AL minus BL? AL minus BL is nothing but AB. LD minus LC is nothing but CD. That's all. That is the proof for this problem. It is very simple. But when you write that AL equal to LD and BL equal to LC, you need to write the reason that the perpendicular drawn from the center to the chord will bisect the chord. That you need to mention. It's very, very important to mention which theorem you are using to get into the proof of this problem. Okay. In any problem, it is important to say the reasons as to why you are writing statements. So even here, you should write mark this as 1, mark this as 2. Say that you are subtracting 2 from 1. It's very important. So we have 2 more problems in this exercise, which we will finish in this class. 3 girls, Reshma, Salma, and Mandeep, are playing a game by standing on a circle. Three girls, Reshma, Salma, and Mandeep, are playing a game by standing on a circle of radius 5 meter drawn in a park. So the radius of this circular park is 5 meter. I mean, they have drawn a circle of radius 5 meter in a park. Reshma throws a ball to Salma, Salma to Mandeep, and Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meters each. So let us locate Reshma, Salma, and Mandeep. They are all standing on the circumference, on the boundary of the circle of radius 5 meters. We will identify the center as O. So Reshma throws a ball to Salma, Salma throws it to Mandeep, and Mandeep throws it to Reshma. It has been given that the distance between Reshma and Salma and between Salma and Mandeep is 6 meters each. So it's been given that this is 6 meters, this is also 6 meters. You're supposed to find the distance between Reshma and Mandeep. You've been given that the radius of the circle is 5 meters. OS is 5 meters. When you write, you need to say that let R, S, and M be the positions of Reshma, Salma, and Mandeep respectively. This you'll mention. You'll also say that O is the center of the circle on which these 3 girls stand. That also you'll mention, okay? You're going to join OR. We are going to mark this point as, say, P. Okay, I'm going to ask you some questions. You're going to answer me over WhatsApp. This is an isosceles triangle, isn't it? RSM is an isosceles triangle. So, we are going to join OS. We are going to join OS. So, this will be perpendicular. You are going to join OP and back to PS in such a way that OP is perpendicular to RM. Okay, now what will this perpendicular do to RM? It will bisect the chord. RP will be equal to PM. Now, consider the triangle ORS. Consider the triangle ORS. If OS is the base of the triangle, Then RP will be the height. Then what will be the area of triangle ORS if OS is the base and RP is the height? So that will be the area of triangle ORS. Now if you consider RS as the base and OQ as the height, then the area of triangle, the same triangle ORS will have area half into OQ into RS, right? Can you find OQ? Is there a way to find out OQ? You can find out OQ using Pythagoras theorem. So triangle OQR is a right angle triangle. So OR square will be equal to OQ square plus RQ square. So you'll be getting OQ equal to 4 centimeters. 4 meter, I mean. So this is half into 4 into RS is, so this is 12. So this is area of ORS. This is also area of ORS. Therefore, both are equal, which means half into OS into X is equal to 12. Therefore, half into what is OS? OS is nothing but the radius. Radius is 5 meters. So 5 into X is equal to 12. Therefore, 5x equal to 24. Therefore, x is equal to 24 divided by 5. Did you understand, girls? Okay, so if you find out the value of x, then What is the distance between Reshma and Mandeep? It will be 2 times x, which it will be 48 divided by 5. Okay. So can we move on to the last problem? Ready? So last problem. A circular park of radius 20 meter is situated in a colony. So there is a circular park and the radius of this park is 20 meter. Three boys, Ankur, Syed, and David, are sitting at equal distances on its boundary, each having a toy telephone in his hands to talk to each other. Find the length of the string of each phone. So all that you've been given is just the radius of the circle, and you have also been given that there is an equilateral triangle that is inscribed in this circle. Ankur, Syed, David. Secularism. Hindu, Muslim, Christian. Ankur, Syed, David. So we have been given that it is an equilateral triangle because they are holding, I mean, they are talking to each other and they are situated on the boundary of the circle. Each of them hold a toy phone and they are linked by wires which are equal in length. Okay, that is what is the assumption. The strings also will be of equal length. Okay, so we are now going to do the same thing what we did in the previous problem. We will find out the area of triangle ASD in two ways. You can see that there are three triangles in this triangle ASD. One is triangle AOS, triangle SOD. Like there are more triangles drawn in this, but we are going to identify three triangles whose areas, if added, will give you the area of triangle ASD. So we can say area of ASD equals area of AOS plus area of AOD plus area of DOS. Now all of these will have equal areas because it's an equilateral triangle. So 20 meters, 20 meters AS, 20 meters, 20 meters SD. AS and SD are equal, right? Therefore, all of these triangles are isosceles triangles and each of these areas will be equal. So I can write this as area of ASD equals 3 into area of AOS. Correct? Because all these areas also will be equal. Now let us consider area of ASD. It is an equilateral triangle. Area of an equilateral triangle equal to root 3 divided by 4 into A square. That is the formula for the area of an equilateral triangle, where A is the length of the side of the triangle. So root 3 by 4 A square. Now consider, now this A square is nothing but the length of the string. Okay. Now consider triangle AOS. Okay. So if you assume this to be x by 2, this will also be equal to x by 2. Okay. Or each of these will be equal to a by 2. We will change the area of equilateral triangle to be root 3 by 4 x square. So the side of the equilateral triangle is each x. Therefore x by 2, and then you have this. So in triangle, instead consider triangle AOL. So this is perpendicular, right? OL is perpendicular. Therefore OA is the hypotenuse. In triangle AOL, OA square equal to AL square plus OL square. OA square equals AL square plus OL square. What is OA square? It is nothing but 20 square equals AL square is x by 2 the whole square plus OL square. You do not know OL. So therefore OL square is equal to 400 minus x by 2 the whole square. Therefore OL is square root of 400 minus x by 2 the whole square. Did you understand until this step clearly? So therefore area of AOS is equal to half into base into height. So the base is AS into height is OL, which is half into x into square root of 400 minus x by 2 the whole square. That's all. That is area of AOS. So here you have an expression for area of AOS. Here also you have an expression for area of AOS. I mean, this is okay. So therefore area of AOS, area of ASD is equal to 3 into area of AOS, which is 3 by 2 into x into square root of 400 minus x by 2 the whole square. Okay, so this is area of ASB. Do you understand, girls? So now we can equate both. So therefore, root 3 by 4 x square is equal to 3 by 2 into x into square root of 400 minus x square by 2. The x by 2 the whole square can be written as x square by 4. Okay. This will get cancelled, and you can also cancel one of these x. So you'll be left with root 3x by 2 is equal to 3 into square root of 400 minus x square divided by 4. Now what are we going to do? We are going to square on both sides in order to get rid of these square roots. Squaring both sides. You'll be getting, when you square root 3, you'll be getting 3. When you square x, you'll be getting x square. When you square 2, you'll be getting 4. Again, when you square 3, you'll be getting 9. When you square the square root of 400 minus x square by 4, you'll be getting 400 minus x square by 4. So 400 minus x square by 4. So again, you can see that this 3 and this 9 will get cancelled with 3 here. So where we have x square by 4 is equal to 3 into 400 minus x square by 4. Therefore, x square by 4 equals 3 into 400 minus 3x square by 4. So you take the minus 3x by 4 to the other side. So you get x square by 4 plus 3x square by 4 equal to 3 into 400. Or you can say 4x square by 4 is equal to 3 into 400. 4 and 4 will get cancelled. So you'll get x square equals 3 into 400. Therefore, x is equal to square root of 3 into 400. So the square root of 400 is nothing but 20, correct? So it is 20 root 3. So we have found that the length of each of these strings will be 20 root 3 centimeter. I mean meter. X is the length of the string. That's what we assumed, correct? So that's how we should do this problem, girls. Did you understand? Okay. So Roshni and Shreya, with that we'll close this class.